Hello, everybody. It's great to be here one more time today. My name is Gary Fowler. I'm the CEO, President, Founder of GSD Get You Done Venture Studios, a premier AI and quantum venture studio located in the heart of Silicon Valley. I'm a 17-time serial entrepreneur with several unicorns under the belt. I was on the original management team at Click Software, which is sold to Salesforce for $1.35 billion. Also, Eva.ai, an AI HR tech company that I co-founded with Dr. David Yang. We believe at GSD that intellectual capacity is evenly spread, but opportunities are not. We are also an operational family office, PR group, GSD Reach, and we're also a development company looking at frontier AI technologies. I'd like to welcome you to GST Presents Top Global Startups, the podcast where I explore the founders, technologies, and ideas shaping the future of the global innovation economy. I'm your host, and I've been working in Silicon Valley for almost 40 years. Today at GSD, we have 184 companies inside our portfolio. Today, we're going to dive into a topic that sits at the intersection of synthetic biology, sustainability, and the future of luxury materials. Our guest today is Michael Newton, the CEO of Qorium, a company pioneering lab-grown leather through cellular agriculture. He brings an extraordinary background that bridges technology, consumer brands, and global scale. He began his career as a private equity investor in New York, focused on scaling cross-border technology, that enabled businesses. He later spent more than a decade at Nike, where he led major growth initiatives and helped drive innovation in new technologies, partnerships, and product development. Now Michael's working on a bold idea, growing leather in a lab. Instead of raising and slaughtering animals, a breakthrough that could dramatically reduce environmental impact. And if we all know, by 2050, we've got to dramatically reduce the number of cattle that we have. We have a rising population. Remember, 26% of methane gas is cows. So the less cows that are slaughtered, the better it is for our environment. Synthetic biology is increasingly becoming one of the most powerful technology platforms of the 21st century. From lab-grown meat to biofabricated materials, we're entering an era where biology becomes programmable manufacturing. So today, I want to explore how cellular agriculture, biotechnology, and advanced material sciences are reshaping industries from fashion to automotive to sustainability. With that, I'd like to introduce Michael to the show. Hi, Michael.
Hey, Gary. How you doing? Good to be with you.
Good to be here. Michael, you've had a fascinating career path from private equity to Nike to leading a synthetic biology company. Why did you decide to form the company, and what's the mission behind Qorium?
Yeah. No, thanks, Gary. It's been a really fun career so far. And the most recent step is indeed working with Qorium. And at Qorium, just to bring it home, we make beautiful leather. Here's a sample that we have. I have a couple here that I can show. All different sexy red. Yeah, you want that one in your car? I think so.
I think that's nice. I had a girlfriend one time that liked shoes that color, and then
Yeah.
she had a pocketbook, and then she wanted a dress.
Yeah, this one's actually a piece we're doing with one of the, luxury automobile companies. But we make great leather. And why is that so important? You mentioned it a little bit in the lead-in. Frankly, from a environmental perspective, the animal supply chain around cows is truly awful. There's 1.55 billion of them in the world. Their impact is huge. But that's not why we're doing this, actually. That's one of the benefits of why we're doing it. But why we're doing it is that we can make beautiful product for the best brands in the world that actually outperforms traditional leather. And that's the key.
Outperforms?
So it outperforms in a number of ways. So we can actually craft the properties of the product to specific applications because of, and we'll get into it, how we use our biosynthetic industrial platform to build the leather. But then on top of it, actually in the processing of the leather, there's a lot of benefits. So as you can imagine, you look at your own skin, I'm sure, like you have blemishes and defects, and you've got a cut or a scar from something. All animal hides have that. Ours don't at all. We have perfectly uniform, precise leather sheets. So every piece is of the top quality across its entire dimensions. Then because it is indeed comes in shapes like this one, perfect rectangle, you're able to actually make product in a way that's much more efficient, has much less waste. Today, if you're looking at some of the kind of world's highest quality handbag companies, they throw out 50% of their final leather, and we can get that down to 10 to 15%. So it makes a huge difference. So between the kind of product characteristics, right, the manufacturing associated with the sustainability of it, totally transparent supply chain, very kind of locally produced in many ways. We just have a product that's better on every front. And so we're excited about developing what I think will be the first really large industrial application of a synthetic biology product.
What made you decide to do it in the Netherlands?
Well, so the founders of the company, I'm not a founder of the company. I was early at the company, but not a founder. The founder are two Dutch guys. And it's actually a really cool story. One of the founders is kind of the world leading scientist in this field. He's an MD, PhD who has done tissue engineering work for his whole career. He actually was the first person in history to build a cultivated beef hamburger. And so he really kicked off the cultivated food kind of push over the last decade. And so he's the expert when it comes to how do you go and how do you build the platform, how do you do the science. But then on the flip side, and leather, as you know from your use of leather, it's a heritage material. It's a luxury material. It's craftsmanship. So our other founder is a guy named Rutger Plume, who has been in the leather industry for more than 30 years. And I kid you not, Gary, he's the 6th generation tanner. And so his family, I think, has been tanning almost longer than the United States has been around. And so just that combination of the science and the art at Qorium is just such a unique opportunity. And they really needed somebody to come in who had the industrialization experience, the commercialization experience, and business leadership experience. And for me, I wanted to do something, having worked at big companies, having been an investor, having done some startups myself. I was ready to get back to somewhere where I thought we could really make a very big impact while building a big company. And I think from what I know about you, Gary, and whatnot, like the way you change the world is through business. And I think we have the opportunity to really change the world. And so it's been a really exciting journey for the past 2.5 or so years, moving this forward and really making beautiful product.
For listeners who may not be familiar with exactly what is lab-grown leather and how is it different from both traditional leather and synthetic alternatives?
Well, it is real leather. We take cells from a cow, so they're bovine cells, and we use those cells through a process we've created to build leather. So the collagen in here and the cross-linking that happens to build this product is exactly the same as it occurs on a cow. Now we can control that and kind of tweak it in certain ways that allow us to think about thickness and strength and different properties in a way that a cow you can't do with. But essentially, it is real leather, and that's our beauty. That's what we always talk about. The only way you're going to replace leather is with real leather. And to your point, Gary, there's a whole section of materials that are synthetic leathers, that tend to use a lot of plastics that, frankly, are pretty low quality. They serve good purposes in and of themselves, and they're, kind of have their applications, but they're not replacing the real leather market. And the leather market is still $100 billion a year business. I mean, it's incredible. And so, we really think about and are very focused on how do we maintain the incredible performance and quality and luxury of real leather, but bring to it a number of benefits that are just undeniably, attractive to the brands and the customers who love that product.
What are the key biological or engineering breakthroughs that made this possible in recent years? And by the way, could that, so if you're doing that, what about for skin grafts? Why couldn't you do skin grafts and make that for burn victims?
Well, those are two excellent questions. Let's do the second one first. So the answer is, I think we could, in the future, apply our technology to build it for human applications. We've chosen not to do that now because, frankly, the regulation and the complexity around doing that is just much higher, much more investment required. Lots of, just frankly, unnecessary hurdles that we can avoid by focusing on what is a very large, very attractive materials market. But I do believe that as you look into the future, we'll take what is a platform now and apply it to different use cases, of which medical will be one. And when you get to a place where you can really make large scale, low cost human tissue, there's a huge number of applications for that. So it's on the roadmap, but it's not anytime soon. In terms of the technology that drives this, there's a number of kind of key technologies that we've invented to create it. First and foremost is actually the cells themselves. So we take a sample. It's a painless biopsy that we take from a cow, and then we actually do work on those cells to genetically modify them to have specific properties for us that allow us to make beautiful leather at scale in an industrial way. So there's a couple things we can, modify them in order to have higher collagen creation. We can modify them so that they live not forever, but we call it immortalized, so that they're much more efficient and longer, kind of called harder working for a longer amount of time. Mm. So a number of different things that we've done to create that proprietary cell bank that we use. Once we have those cells, we need to proliferate them like crazy. And there's actually not a lot of proprietary technology in that stuff. We've optimized the process, we know how to do it, but a lot of people are doing that proliferation step. And so for us, that's more about just ensuring we're doing it efficiently and as effectively as possible. But the second place where we have truly the real unlock in terms of new technology creation and the IP we have around it is what we refer to as a tissue bioreactor. So this is a piece of equipment that we've developed that allows us to actually grow very large sheets of collagen, right, that gets turned into leather, and do that in a way that's efficient and very, again, as we talked about, very uniform, very precise. And so this is a machine, we own all the IP around it. It's frankly, it's a pretty cool piece of technology to basically be able to say, hey, skin's normally grown on a cow. It takes like 2 years to get there if you go from the initial gestation period all the way through the slaughter of the cow. We can do that in, just a couple of weeks and get really high quality product throughout. It's very cool, but the technology is, very cutting edge, and we're still early stage, right? We're still working to fully industrialize it right now.
What are the biological or engineering breakthroughs that made this possible in recent years? And then the other part is, you talk about growing it, but how difficult is it to grow the leather at industrial scale?
It's difficult because it really is. I've built in my career, I've done a lot of work building large factories and businesses where you're looking at electrical engineering, software engineering, mechanical, those sorts of things, chemistry. And all of those, you kind of solve a problem and you move on. You solve a problem and you move on, and you can work through that. The intradependencies within a biological system are just like super complex. So you make an improvement to one part of the system and something else changes. And so the real solution here, and what I think makes what we do so unique and why our scientific team is so awesome, is that you have to be able to optimize continuously against what is a very complicated process and build the kind of recipes to do that. So all of our investors and everything are very focused on, hey, what filed IP do you have and whatnot? And we do have a lot, and that's important. But actually, it is the unique kind of trade secret about how you build an optimized full system to grow, what is real tissue. And there's nobody else in the world doing that in the way that we're doing it.
So can you call it leather when it's, when you put it out? Do you call it leather? Or is it synthetic leather, or what do you say?
So it's leather. For us, it is leather because it has the same structure. It's made with the same proteins. It is leather. Now, certain countries are taking different points of view on that. Actually, mostly not to do with our technology, but mostly to protect against other like leather imitators. And so whether the pleather stuff or some of the ones that use, plant-based materials or whatnot, there's some, countries where this is very important to their history, Italy and places like that. And so they have very strong, kind of lobbies that want to protect that name, kind of similar to champagne, or other kind of names like that. So for us, it's leather. Around the world, in most places, it's going to be called leather. But, we really think about it as being the pinnacle of leather because it actually is everything that's good about leather, plus, plus, plus.
So how close are we at this point to achieving cost parity with traditional leather production? How much cost differential to do it your way versus traditional leather?
Currently, it's meaningfully more expensive. We've reduced the cost dramatically. But first, it's important to understand the leather industry is, as I mentioned, about $100 billion a year. The top of that industry is, kind of where we're focusing. And so that's where you get, leather prices that are, those are high quality, very, very, kind of luxurious pieces of leather used in the types of applications that I think we all think about normally. But there's actually a ton of other leather uses, all the way down to, I worked there for a long time. You buy a pair of Air Force Ones from Nike, and those are leather, but it's actually relatively low quality, it's actually coated with plastics and other things as well. So we're focused on that top end. We believe we can get to parity within the next couple of years. And that's a combination of essentially two things, Gary. One is we have to drive greater efficiency in the process. And so there are 8 measures for how we drive our bioprocess in this platform that we're just continuing to improve on kind of a quarter by quarter basis. The second piece is just you need scale behind it. You need to be able to build a factory that has just not enough economies of scale. And actually, the volume you need to achieve the economies of scale is not that huge. So, once you get to making a couple 100,000 square meters of leather per year, you're at a place where you're actually able to start to achieve parity with current leather prices. And that's not including, as I mentioned before, we eliminate a ton of waste. So if you're a French high-end luxury handbag company, and let's say, make it up, you're paying 100 euros per square meter of leather, and you throw away 50% of it, obviously your effective cost is 200 euros per square meter. We're able to actually be price competitive without thinking about the waste. So there's actually a lot of value we can capture and share with our customers as well.
How much carbon, water, and land use could be reduced if the industry moved towards lab-grown materials?
It's massive. So as you mentioned a little bit, there's 1.55 billion cattle in the world, right? It's the number one source, as you mentioned, of methane emissions, number one source for deforestation, and huge user of water and all that. From our technology, and we've done an independent life cycle analysis with a third party, they conducted it, not us. And we're looking at an 87% reduction in carbon. You're looking at about 65% reduction in water use. And then from a land use perspective, it's not even comparable. It's like 99% plus reduction. And so there's just a huge impact that you can make from a sustainability point of view. Now, if you think about it on a global point, it's a little bit more complicated because cows make many products, right? Everybody thinks cows make meat and that's where the money is and that's the only thing. It's actually not the case, Gary. So cows make meat by volume and by total dollars. That's actually the largest economic driver of that cattle supply chain. But the leather is actually the highest profitability in it. And then if you look at there's this kind of category called offal, which is all these other things that get used into medical purposes and go into jelly beans and stuff like that. There's a wide range. So by pulling out the profit that's driven from the leather, we can start to move really the economics in such a way that drives a broader change to that cattle supply chain. And as other technologies, other alternative proteins come online, we can then really start to take a bit of a cut and say, hey, let's get rid of these cows. Let's move them away, because the cow's an amazing animal. Frankly, it's the most impactful animal on human development in our history. I've actually studied that. I gave a keynote on that. We really look at that. But the cow has now become the problem. And so how do we harness what's best about the cow? How do we leverage this industrial biotech? And let's build what we need precisely and efficiently.
So we're going to see major fashion brands launching biofabricated luxury products soon, or are they going to stay on the bench and not do anything?
It depends on the brands. But there's just being transparent, there's been a bit of an up and down in this industry. There's been a lot of promises that have been made in the past around certain materials. A lot of those materials were kind of hyped a ton, and some brands did dive in and release, some products, but nothing's ever gotten to scale, and nothing with the brands that, really make a difference in the world. And so, the key is now, can we put a product on the table that meets great quality product, good manufacturing at a price point that works, available at the scale they need. And so we believe, and it gets back to what I said before, the only way to replace leather is with real leather. And so if we can do what we're doing right now, that will be the breakthrough that's required to really get a true change at scale in the industry. And we talk to and are working with some of the biggest brands in Paris and Germany and other places around the world. And they're not going to compromise on quality. They're not going to compromise on cost. I understand that. I worked at Nike for years. You got to meet the consumer expectation. But if we can deliver the promise, there's no barriers here. The amount of enthusiasm for what we're doing is just super high.
Um, from an investment standpoint, do you believe biomanufacturing could become $1 trillion sector? Is it that powerful? And what's it going to take to get it to make the ball move forward faster?
Yeah, Gary, this is actually why I ultimately got really excited about this. I'm not a biotech guy, right? Like I was an investor, I'm an operator, run manufacturing, supply chain, digital technology, all that, not biotech. But when I was looking to do something different after having worked at Nike, I wanted to be involved in a sector that I thought could have a huge impact and was at kind of, early in its development. I am 100% convinced that synthetic biology is going to be the next kind of key unlock for how we manufacture in this world. Now, to say how long is it going to take and where it is, Amazon always says it's day one, right? You can talk about, American analogy, you're in the first inning. Like the game hasn't even started here. Our understanding of like the biological pathways and processes that we will need to learn how to understand is really just started. We've made tremendous progress, Qorium for sure, but the industry and science overall. But I think once you start to see real AI-driven unlocks where we can understand and replicate through digital twins truly how biological systems work, you're going to get to a place where it's just a whole different game. And, just put it for example, if you had dense cultivated food manufacturing, everyone's like, oh, you're never going to have enough land, you're never going to have enough this. It's bullshit. You can put in the size of Manhattan, right, enough manufacturing to feed the entire country.
Wow.
Right. And so that's just like highly much more efficient and frankly will be much more cost effective too, because nobody thinks about all the externalities of our current food system and whatnot too. So I really do believe that everything from materials to food, and then you start getting into some of the really crazy stuff that biomanufacturing in the future will be able to do. I'm a big believer in that, but we've got a lot of work ahead of us. I do think that AI, which is, you hear about AlphaFold, you hear about all this stuff in biology. Frankly, those are small applications currently. Once you start getting the ability to really apply it to kind of the companies like ours, which we're very much working on right now, that's when I think you're going to see an acceleration that will be truly exciting.
So what's been the hardest challenge in building a synthetic biology startup? Is it the education that people don't get it? I suspect you're going to have a lot of that, right?
The hardest challenge is raising the money to put this to work. Yeah. It's interesting, for us in particular, right? We make beautiful materials. So a lot of biotech investors don't understand our market. If you talk to a lot of materials people and consumer investors and all that stuff, they don't understand the technology, right? A lot of the, frankly, just the whole sustainability and, kind of ESG sector is just out of fashion right now too. So, we kind of fall in a difficult, a little bit in between the Venn diagram overlaps. And so we're lucky we just raised our Series A, have a great group of investors who are super supportive. And we've very much built our roadmap to be as capital efficient as possible. But we're still going to need to raise, in total 80 to 90 million euros to get this thing to profitability. And it's just, that's a tough story. And I get it, right? I've been an investor. And if you say, okay, I'm going to be involved in something that's kind of a 7-year project, or I can look at something that is a 2-3 year turnaround on the AI or defense tech space or whatnot. And so capital's moved as you expect it to. But I'm a big believer, hey, like hard things are hard. You've got to roll up your sleeves and get them done. Working on true physical products that drive our daily life is like a very important space, and it doesn't get as much focus, and I don't think it gets the same talent at times. And so I'm excited to be like really picking apart what is a hard challenge, but you got to be in it for the long term. And that's where right now, from a funding point of view, we see just a gap between what's realistic from a platform development and science point of view and the expectations around time to market and scaling.
Yeah. So, what's been the hardest challenge? So sounds like the hardest challenge is getting the word out, right? Education, whenever you're in a new market, is critically important because people don't know what they don't know. And so I think the idea is, fantastic. I remember one time having Connolly leather seats that were so beautiful.
No.
And boy, I'd love to have another set of those seats. But, if you have the technology like yours to be able to do it, you could do it in relatively short order. And these are, when you take an integrated approach to climate change, these are some of the things that are going to be critically important. the sum of the parts equal the whole. It's alternative fuels. There's all kinds of things. So we're not going to be around, to be honest with you. We can't keep living the way we're living now.
No, no. I mean, using a cow as a factory is just a really dumb thing to do. I mean, sorry to put it so bluntly, but it's like an incredibly inefficient factory, right? Like if we made anything else, like we make the proteins that a cow creates, we would just never accept it, right? And so like we just have to build systems that are just much more efficient and productive in how they work. And we can leverage those best, tools that Mother Nature gives us to do it. We're just learning how to do that now. But yeah, people don't, the storytelling and the understanding. I mean, we're a deep tech company, right? What does that deep tech mean? It's a term that gets thrown around all the time. For me, it's like super simple. We have a shitload of science we have to prove out, and we've got to build the market at the same time. And we're lucky because I think we're going into a huge, very established market, but still, I still think about having to build that market all the time because to your point, you've got to evangelize it. You got to make sure everybody understands it. And for a lot of people, even though the benefits are very clear, they just don't like change. And, there's just a lot of other things on their plate. And so that's the work that we have to constantly do, storytell, right? Sow those seeds so we can harvest them later.
If we had this conversation again in 10 years, what do you think the materials industry will look like?
Well, I mean, I think in 10 years, the leather industry will have been significantly impacted by our technology. There's no doubt about it. But then if you look at a whole range of other materials, whether it be let's talk about the big ones, the polyesters, the cottons, and all those, all the natural materials will move in more to kind of call it synthetic biology sources. And you're seeing that with, cotton, synthetic biology cotton, right, cultivated cotton, stuff like that, which is pretty interesting. I think what you're going to see more and more on the kind of all the oil-derived materials, the polyesters and other things, is essentially infinite, fully recyclable, closed-loop systems. And there's some really neat technology. There's actually a company just up the road here in the Netherlands from us. There's an American company called Cirque. There's a number of companies who have finally kind of cracked the code and are starting going to scale now on commercial grade, commercial volume factories to be able to do that. So when I worked at Nike, one of the coolest products, Gary, I worked on was something called Nike Flynet. And it was a technology that we would take in, bottles, plastic bottles, we'd recycle that, turn it into the material of the upper. And one, obviously just the pure material itself was way better because it was recycled. But then we were actually using 3D knitted technology to basically additively manufacture a piece of the shoe. So you reduce waste by 99%. It was much more efficient. Like you're just going to see more systems like that. That really makes sense. And I have a friend right now who's out in Taiwan who's, really just cracking the code on a fully recyclable closed loop shoe, infinitely recyclable. Those are the types of things that in 10 years, I think will become very common and will make a huge difference in how we think about, kind of the life cycle of any product that we have.
No, you're right about it. We have a lot of challenges in front of us, and these kind of technologies, just like what we have, to be able to keep our quality of life up, you want to get leather seats instead of those velour kind of seats. This is one of the ways to be able to do it. So I applaud you. Listen, we're coming up to the top of the show. Michael, if you had to leave our listeners with one thought about the future of synthetic biology in sustainable materials, what would it be?
I think what I would just say to people is don't compromise. Right. So we know that consumers will never compromise on quality. They certainly don't compromise on price. But the technologies and the materials are now becoming available that if consumers start to demand it, we can start to drive real change. We talked about fundraising as being a big challenge. But if we have companies now who are hearing from their customers that, hey, guys, you're able to do better and we demand it, that makes all the difference because then you start to get those companies starting to look upstream, supporting companies like us, helping us get the funding we need, and you get the flywheel and innovation going much more. And so I say it all the time, Qorium is an amazing company. We build a great material. It's going to be available at a normal, non-premium price. It's going to give an experience that everybody wants, and it's going to teach the consumer to demand so much more. And so don't compromise. And I think that's what we should see. People are very used to doing that. And I think we need them to push brands to do better. And the solutions are available.
No, that's great. Well, I appreciate you for taking time out of your busy schedule to join me today. And I want to thank all my audience for joining one more time. GSD presents Top Global Startups. Michael, I love the conversation, and people don't understand how important it is for these alternative materials to be able to come out. So on one is we keep the quality of what we have high. On the other side, we're going down through and helping our environment. It's critically important today. It was
Yeah.
my speech at the UN called "Technology is a Tool for Peace." We've got to get down through, and we got some hard decisions to make. Sometimes we forget though, Michael, because we're not on this planet long enough, and we think, well, it's not going to bother us. But the problem is going to bother your kids and grandkids, and that's where it starts to be. We better find a solution now before it's a huge problem, right?
Yeah, absolutely.
Well,
Absolutely. So, Gary, really appreciate the time. It's been fun to chat.
yeah, no, and thank you, and thanks to all my audience one more time for joining GSD Presents Top Global Startups. Because of all of you, we're now at 1,600 podcasts. Check out, I've written about 900 articles, and my ninth book is coming out. My last book, How Stem Cells Changed Me, is out there, so check it out. Stay happy, stay safe, and stay healthy. We'll be back to you again soon with another exciting edition of GST Presents Top Global Startups. Take care of yourself and take care, Michael.
Cheers. Thanks.